Recording before I forget it. Let's see here. All right, so we're in week 7. Some of you may have noticed I did move the exam 2 date back. I did that on Monday actually because I had a few students that had some technical issues, and we've been working through those. So I extended the date for the exam to this Sunday instead of last Sunday, but I technically moved it on Monday because I realized we couldn't work it through. But so that's why we don't have another exam. This is the one from last week, but it's just out there because certain students had an issue with some of their equipment and or Proctorio. And so that's why that was done. So there is not another exam. It's the same one. And then let's see here. We'll go into week 7. One of the things, right? So we're covering chapter 6 and 9, but you should be starting to working on the final exam lab, right? So this is due in finals week. It is worth 1/3 of your final exam grade. So, the exam itself is 2/3 of the final exam, and then this lab is 1/3 of the final exam grade. So it's due in week 10. It's just a regular packet tracer lab. Let's see here. Let me go ahead and download it here. Okay, so mainly it's using the book, right? So it's the capstone projects, chapter 7, capstone project 7-2, chapter 8, 8-1, 8-2, and 8-3, right? So it does reference project 6-1, but you can ignore it. You did the packet tracer course, and that was basically what 6.1 is kind of about. So it's dealing with these 4 capstone projects in the book. So you get all the instructions from there, and I've given you some hints here, but it's in the book, and you just follow it through step by step and build the network out. Please use the template though that I've provided here to build it out. So it'll take some time. Like I said, it's 4 of the capstone projects in the book, so don't leave it too long, right? Don't procrastinate too long. You'll want to start working on that. This week also we have the wireless radius lab that is due, and our regular chapter questions, and then the rough draft, right? So the 3 pages that are due this Sunday on the video that you watched, right? So you did the outline and introduction paragraph, and now you do at least three pages for the rough draft, and then the in week 9, the final paper, the full 6 pages is due. And does that say 8 pages? Okay, that says, but no more than 8, right? Yeah, so 6 pages, but no more than 8 will be due in week 9. So don't forget to do that, the rough draft. And then we have the wireless radius lab. And this also can be found in the book, but it's the hands-on projects, not a capstone project, chapter 10-1. But mainly you're going to take a wireless router, WRT 300N. You're going to configure it to use Enterprise, WPA2 Enterprise. And so you're going to also have a generic laptop, configure the generic laptop, put the wireless card into the laptop. Then you're going to configure the wireless router to use a Radius server and using AES encryption. And then you're going to have a Radius server and configure that Radius server and to use the AAA service, which is Radius. It'll connect to the router, and then it will have the user database so that the wireless laptop can connect. So that is pretty much it. Is basically setting up WPA2 Enterprise. So you'll have a laptop. Let's just see here. Just have you'll have a laptop. You'll have a, where is the wireless? Wireless router, and then you'll have a server, right? So basically the laptop will connect to the wireless router. The router will say, hey, authenticate them. It'll grab the username and password and authenticate the user. If it says okay, it'll say, yep, it's okay. And then it'll allow it to connect. So that's this wireless Radius lab. But once again, it follows the hands-on projects in chapter 10, project 10-1. So you can go through that as well. And then there's a wireless lab. So there's 2 steps to it. It's actually just going to this web page, to these web pages, and then going through configuring a wireless router. You're just going through and viewing and looking at a lot of it. Some of it is configuring, like the port forwarding or whatever, setting in the where would you set in the port forwarding for RDP, things like that. But it's just getting to know the interface of wireless routers. And I even include the manual, but for the most part, you just take snapshots of the steps showing that you were able to find it, is basically what it is. Any questions? That's actually quite a lot this week that's due. Okay, what, the wireless lab, you need the manual for any config? No, I just included it. It's just there for you to go through if you need to see anything to know that you're where you need to be. But for the most part, let's get over into the right. Right. So the most part, you're just going through and finding the locations of where things are, where would you configure it, right? And just doing a snapshot. So like, basic setup, highlight the host name, right? The host name, right? So you take a snapshot and highlight this host name, right? So it's just showing me that you can locate what's in that step, right? You're just highlighting, like the router password, security firewall. Where would you find that, right? And so you would go to, yeah, right. So right, an RDP, right? right? So, right. So the applications gaming port forwarding, right? So applications gaming, right? Single port forwarding, right? You're not doing the port, so the single port forwarding is fine. So RDP is not listed, right? But it is here on the screen. You would just do RDP, and then you would put 3389, 3389, right? So, and then you could, do TCP, UDP, or both, right? So this is where you would do the port forwarding. RDP is just not listed. You would actually just put it in. Yeah, yeah, no worries. Yeah, but it's really just so that you get familiar with the management of where, where would you find certain things. I know it's all different in different routers and that, but it's just something that you can get through and get exposure to the wireless routers, and you can play with these and do, I mean, you can't really test it out too much, but that's also why I gave the manual if you wanted to go into it a little bit more detail and learn more about what settings are available. But for the assignment, it's just mainly, can you find it, right? All right. Any other questions for this week's assignments? Let's see here. Let's see. Okay. Okay. All right. Okay. All right. So we did have some questions on the practical subnetting in the. I know I just included this with the subnetting assignments. So that was glad that you actually asked those questions. So I'm going to go over a little bit on these, and I still couldn't figure out the. Okay, sure, we can go over that one too. Yeah, 21,590th subnet. We can definitely do that one. Don't need that. All right. Well, and I did realize you are correct. These are not accurate. So this problem 3 here, practical subnetting 3, right? So basically, let's go. Let me go to the student book, right? So the student book tells us that we're given these networks here below, and we need to design a classful networking addressing scheme that will supply the minimum number of hosts. Okay, so well, that's the minimum number. Okay, so minimum number of hosts, and allow enough extra subnets. I guess I didn't catch that minimum. So yeah, so we want to do the minimum number. So of hosts and allow for 25% growth in this area. All right, so basically the first thing you need to do is figure out, well, how many networks do you have, right? So you have, off the router, you have 1, 2, 3, 4 networks, right? And so then we would put our number 4 here. So I'll go back to the instructor's guide. So there's four networks. We need 1 for growth, 25% growth. So that's 5. So it's larger than 3. So we need at least 8 networks, right? Because you can either have 2, 4, 8, or 16, right? So we need at least 8, but our directions say to minimize the number of hosts. So we need to figure out how many hosts, right? So we got 30, 50, and 185, right? And then we add for growth is 232, right? So we need at least 232 for growth. So to minimize that, um, we can go to, we take all 8 bits for the subnet, and that leaves us 250 or 265 hosts, which minimizes our number of hosts, right? Because we do 256, 265, and that's the smallest amount. And that's so because this is our minimum number of hosts per subnet is what our directions are. Otherwise, um, you know, if we just did this to maximize the hosts, right? Um, we could set this at was it 224, right? So that would give us 8 networks, and it would give us 5 bits on top of the 8 bits, so it'd be 13 bits. So that would give us a lot of hosts. But since it said we needed to minimize the number of hosts, we took 8 bits, right, and left 8 bits for hosts. So then once we have that, since we're doing 8 bits, we're going up here at the third octet, right? So 0, 1, 2, 3, you know, and we have 265 networks now, even though we only needed 5, and right now we only have 4. So we have these first 4, and they each have 265 hosts. So they go from 0 to 255, 0 to 255. Does that make sense? Is there anything that you want me to go over? Right. Okay. Yeah, that looks okay. All right. Um, let's see here. We can do another one here. You were also saying 7, right? I didn't know why they were borrowing 8 instead. Oh, right. Yeah. Yeah. And I missed that the first time I read that this morning when I was prepping for this. I missed this, right? So this was the requirement, right? Is to minimize the number of hosts, right? So that's why they took 8 instead of 3. Yeah. 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 So then. Because yeah, normally, right, you would yeah, and normally you would maximize for hosts because that's more likely that you're going to have hosts than networks, right? Because you're um, taking 3 gives you 8, and even with 25% growth, that you can actually do 100% growth on networks. So 3 would be more ideal because I would think that you could add more hosts than you would add networks. But that was not our instructions. So, but yeah, and so yeah, right, yeah. So with 7, yeah, it's the same one. Yeah, minimizing the number of hosts per subnet. Yeah, that's a very odd direction. Right, very unintuitive. Yeah, you're maximizing number of networks and minimizing the number of hosts, which is really probably counterintuitive and opposite of what you would probably do in the real world. Um, but yeah, but yeah, so that you're maximizing networks and minimizing hosts. So that's the issue with these. Yeah, and that's the ones that looks like you rightfully questioned. Uh, and right, so yep. So we'll just go over this here real quick, but so and in this one here too. yeah, they come up with 4 networks, although you could technically um, say that each one of these is a network if you were using VLANs, right? Um, so, but they didn't tell us that we were using VLANs, so we're just assuming that they have off the one router, they have one network, so they're all on the same network. Um, but but then because they're on the same network, you got to add all these hosts, right? So that's your largest host, um, which is 363 plus the growth of 454 means we need 817 to handle our largest subnet with growth. So at least we're adding some decent growth in here, although we're maximizing the networks instead of uh, the host, right? Um, so right, we only need 9 subnets, so we could technically get by with 4 bits, right? But they chose to take 6 bits because we're minimizing hosts, and so I can see where you would have issues with that, but because taking four bits would give us 16, which is double, almost double the double growth, right? I mean, you would think that would be more than enough networks. Um, but because we're minimizing for hosts, we still take 2 more bits, and we go to 252. We take 6 bits, which leaves us with 10 bits or 1024, which is the smallest number of hosts that we can have and accommodate for growth. And then because we're doing with the 6 bits, we're going up by 4 each time. And so that we've got 1024, yeah, 1024 IPs per network. All right, let's see here. So how can I do the 21,590, right? Let's do it this way. Let me, all right, so we've got 21,590. We've got the IP address. Oh, what is that IP address? Let's see here. Oh, it's 10 network. Thank you. Thank you. All right, so yeah, 10.0.0.0. All right. And so it's going to be a /25, you said? All right. Yeah, okay. Yeah, let's not let me do that. Let's do, okay. All right. So basically it's going to be 25, 25, 25, 128. That's our subnet mask. All right. So you've got 10, 0, 0, 0, right? Is our first network IP. And so then our next network IP is going to be 0, 0, 128, 10, 0, 1, 0, 10, 0, 1, 128, right? 10, 0, 2. All right, so that we got 1, So we'll just take it out a little bit here. 2, 1, 8. All right. 10, 0, 3. All right. Okay. So this will keep going, but all right. So you've got 2, right? For every number you have 2, right? So 28, because we have 1 bit here for networks, right? In this last octet. So you've got the first, second, third, fourth octet, right? So in the fourth octet, right, we've got 1 bit. So we're going to go 2 for each time, right? We have 2 networks that we go through, and every time we do 2, right, then we go up 1, right? And so we're going to go up all the way until this gets down to 255, and then it's going to be 255, 0, 255, 128, and then it's finally going to go to 1 and start all over, right? And then this will go all, 2 to 255, right? But there's going to be 2 of them, right? So it'll be 1, 0, 128. Whoops. Yeah. Eventually, you'll get through all of that again, and you'll get to 1, 255, 0, and 1, 255, 128, and then it'll go to 2, right? And then, but this will eventually go, you'll do that until 255, right? So, whoops. And that'll be the 131,000, right? 772 or something like that network, right? But we want the 21,590th network, right? So this is 256, and this is 256, right? So for every time it goes up 1 in the second octet, every time you go up by 1, it's went through 2 times 256, or 512 networks, right? So for every number here, it goes up 512 networks. So we can take this number and divide by this number, by 512. That gives us 42. So that's telling me that 10.42 is going to be part of our answer, right? So it's got a remainder, so it's not even. So we've got equals 2159 minus the 512, oops, times 42. Right, so that leaves me 86. That's what this remainder is, right? So there's like 86 networks that are left, right? So I've got that. So now I want to figure out this number here, right? So this number changes every 2, right? So 0, 128, 1, 0, 128, 2, right? So it's changing every 2. So now I take this number, divide that by 2, and I get 43. And so this is where it gets a little odd, because the odd, if you see here how it goes by the odds, so the odds are zeros, right? So 3 is 0, 5 is 0, 7 is 0. Um, and then it'll keep going that way. But you got to take one because we're zero based, right? Why is this working out that way? Because it should be 42. 42, 128 should be the number. So why is that? Maybe 42. Did I do something wrong here? Because I'm showing this should be 42, 0, but it should be 42, 128. All right, I'm gonna, yeah, because the way I'm looking at this, it should be 42, 0, but I'm almost 100% sure that it should be 128. So I'm gonna cheat. 10 network. We're gonna do a slash 25. Few subnets. All right, copy these, add a new sheet. And we'll do subnet 1. All right. You know what? Just do this. That's probably not going to work either, but 10.42, 42, 28. All right. So it is the 128 network. All right. So I was correct. It was 42, 42, 128. That equals 42, 43, 43. Well, because, oh, that's why. Because I'm not doing these numbers. Never mind. So because I got 43, right? That means it's halfway between 42 and 44. 44 would have been the 40, would actually be 43. Yeah. So it'd be 128. Because it's 42 and a half. It's, because it's 42 plus one more. If it were 44, it would be, you know, the 43. Um, but really the big one is to get this, knowing that it's going up by 512 networks. Divide that by the network number you need divided by, you know, how many networks are in there, and you get that 42. Then you divide that by the next one is 2, right? So you're dividing it by 256 times 2 the first time. That gets you the second octet. Then you're dividing by 2 to get the third octet, and then it just, you know, it's going to tell you also the fourth octet as well, from that answer. But that's how you would do it, is just knowing how many networks, revolutions does it take to get there. You're just dividing and subtracting it through. I know it's not 100%, but I mean, does it make sense? I mean, most of the time you're not going to do it that way. You're going to use the subnet calculator if you're dealing with 130 some thousand networks, because there's just no way I remember that calculator for it to do it. Yeah. Yeah, there is a calculator to do it. Yeah, definitely. But you can do it by hand. I mean, uh, it's not 100% precise, but yeah, uh, because it gets a little wiggy here to get that last octet. Um, but it is really, just the, how many networks are you dealing with, and you know, what's the network number you're looking for, and how many, how many octets are being used for the network. Most of the time you're not doing anything like this. This is, this is huge. It's just, it was kind of crazy. It was just give you an idea, of what is possible. Uh, but I mean, to create 130 some thousand networks is just absurd. uh, Normally you're dealing with more manageable, size networks, in the hundreds or 200s, that they're very easy to deal with. All right. Any other questions? You're good. Okay. All right. Uh, this. All right. So then let's go. Final exam lab. We have to reference to the text. Yes, the final exam lab. It is all in the, textbook. It is the 4 capstone projects. In fact, let me go ahead and pull that up. Yeah. Um, let's just go here real quick. Right. So. Now, there is, I will say, it is a little, uh, interesting, because they're in the, let's see here, because you will actually build part of it and you'll mess it up. Yeah, it builds on each other. So, let's see here. New questions. Okay, so there's hands-on projects, but these are capstone projects. So, um, unlike the wireless one, which is a hand-on project. capstone projects. Okay. So this is 7.1 and 7.2. So building a packet tracer network. This is the one you start with, right? Um, and so it's a capstone project 7.2, and you build out this network here, and set it up. And then you'll go to chapter 8, and did I miss project 8.3? No, it looks like it, but why is that? Okay, so we are in it somehow. Ah, there we go. So the capstones projects 8-1, 8-2, and 8-3, right? So you'll add to your 7-1, and then this was 7-1, and then you'll add more to it. You add the router, and you'll configure it, and follow it step by step. It shows you what you're doing with each one. Gives you ideas, it does some subnetting, um, but it's nowhere near as challenging as the subnetting one that I created. Then 8.2, you add VLANs to the network. Uh, and you add access modes, right? So trunk ports. And then final, let's see, and still configuring DHCP on some of them. All right. Yeah. Yep. And then save it and submit it, right? So, but it's 7.2, 8.1, 8.2, and 8.3. Yeah. Oh, you're welcome. But it's in the book at the end of the chapters. And let's see here. So, it's week 7. All right. So I guess we need to go over our quizzes, unless anyone has anything else that they want to cover. All right. All right. Question 1. What type of device can be used to assess the quality of a wireless signal? D. That's a good guess. It's actually a spectrum analyzer, but I would call it a Wi-Fi analyzer too. That's kind of a bad choice, but it's actually technical term is a spectrum analyzer. Yeah. If you need to evaluate Wi-Fi network availability, close enough, except for the quiz. Yeah, I know, right? Yeah, if you need to evaluate Wi-Fi network availability as well as optimize Wi-Fi signal settings and identify security threats, what tools should you use? Wi-Fi analyzer. Um, Setting, identify spectrum protocol, air scanner. Yeah, probably is a Wi-Fi analyzer. See, protocol analyzer. And settings, identify security threats. What tool would you use? Uh, yeah, I think this is just running through the quiz a little bit, but I haven't gone through these as much. You're guessing. Um, yeah, I'm not sure what they're thinking about here. I mean, the spectrum analyzer is going to do that. I'll say it's a Wi-Fi. Yeah, I mean, reads protocols. I could go with that. I can go with protocols. I mean, signal settings and identify security threats. I'm still thinking it's a spectrum analyzer, but because to optimize signal settings, you would need to analyze the spectrum. So that's an odd one for me. Yeah, because I don't see anything that stands out other than the spectrum analyzer. So we'll see. We'll see on this one. Yeah, the Wi-Fi analyzer. Yeah. Okay. All right, we'll go with the Wi-Fi analyzer on this then, if they say that exists in the text. Okay, we'll go with Wi-Fi analyzer. The wireless personal area network is defined in the 802.15 standard. True or false? True. Yeah. Hey, Z-wave transmissions have a range of up to 50 meters per hop and can tolerate up to 8 hops through repeaters. True or false? That is false, right? I believe they're 100 meters. How does refraction affect the propagation of wireless transmission? Hey, yeah, right. It distorts the signal as it travels through a different transmissions medium. NFC tags are very expensive and cannot be purchased blank, requiring them to be preloaded. Once again, my power is immeasurable. Awesome. Yeah, false. They're cheap and come be blank, right? So yeah, if they were expensive, they wouldn't be very useful. At what layer of the OSI model do the 802.11 standards vary? D. Yep, physical layer. Yes. How many data streams are used in the 802.11 AC Wave 2 device? Good guess. It is 4. How does the 802.11 data frame indicate how a large packet should be fragmented? Frame sequence checks dedicates the calculated packet size. It's the sequence control. C, the sequence control field indicates how packets will be subdivided, but that was a good guess. Yeah. Uh, Upon connecting to a Wi-Fi network, you're redirected to a login screen and requested to accept terms of service before being connected. What is this an example of? D. Yes, it is a captive portal. The most secure Wi-Fi communication is made possible by combining a radius server with WPA or WPA WPA2, known as WPA Enterprise or WPA2 Enterprise. True, right, and that's our wireless radius lab that we're doing this week. The use of the multiple antennas on an access point to issue a signal to one or more receivers is enabled by what 802.11 innovation? No, it's not spread spectrum frequency hopping. That's a security feature, but it's the multiple input, multiple output, MIMO. Yeah, yeah, gone with your gut. Yeah. Uh, Infrared technology uses an LED that emits light with shorter wavelengths than red light. That is false, right? Yeah. What is the purpose of the layer 2 LLC sublayer? That is a really good guess, right? You would think layer 2 with the MAC address, right? That you would think that would be correct, but it is actually A. It deals with multiplexing, flow and error control, and reliability. But that was a really that is a good guess. Yeah. Due to many vulnerabilities and a short key length, the WPA security standard was replaced with WEP, WEP. Yes, that is definitely false, right? Yeah, it is the other way around. Exactly. Yeah, WEP was replaced by WPA. Diffraction has what effect on wireless signals propagation? Yeah, good. Yeah, D, the signal is split into secondary waves that continue in the direction in which they split. All right. When using RFID, what is an ARPT, active reader passive tag? C, yes, right. It's a tag that is activated by the active reader and uses the power from the reader's radio to power its transmission. So yeah, it's really cool design how they did that. All wireless signals are carried through the air by electromagnetic waves. Yes, that is true. And what scenario describes an evil twin attack? A, right. A malicious access point is configured with an SSID of a non-malicious public access point. They try to fool you. Yeah, it's an evil twin attack. 802.11 data frame contains four address fields in contrast to the two address fields in 802.3. Yeah, the pineapple was pretty nice to know. Yeah, exactly. The Wi-Fi pineapple for that evil twin attack. Exactly. Yeah, yeah. True. Right. Right. We have four address fields in 802.11 instead of two. Yeah. Uh, And we got them all right. Awesome, right? So the spectrum analyzer is the device to assess the quality of wireless signals, and it's the Wi-Fi analyzer if you need to evaluate the network availability as well as optimize the Wi-Fi signal setting and identify security threats. So we would use the Wi-Fi analyzer for that. But the quality of signal we use the spectrum analyzer for. All right. The wireless personal area network is defined by 802.15. Z-Wave, like I said, I believe has a range of 100 meters, so this is false. How does refraction affect the propagation of wireless? It distorts the signals as it travels into and through a different transmission media. NFC tags are inexpensive, so this is false. At what layer of the OSI do the 802.11 standards vary? And it is the physical layer. We do have 4 data streams that are used in the 802.11 AC Wave 2 devices. The sequence control field indicates how many packets will be subdivided, right? So that's how our large packets will be fragmented from our sequence control field. Connecting to a Wi-Fi network, you're directed to a login screen and request to accept terms of service before connecting is an example of a captive portal. And then the most secure Wi-Fi communication is made possible by combining a radius server with WPA or WPA2, also known as WPA Enterprise or WPA2 Enterprise. And then the use of multiple antennas on an access point is possible because of our multiple input, multiple output innovation. Just think multiple antennas, right? So multiple in, multiple out, right? We need multiple input and we need multiple antennas. Infrared technology utilizes LED that emits light waves that are longer wavelengths than red light because it's not shorter, so it's false. Our layer 2 LLC sublayer is used to handle multiplexing, flow and error control, and reliability. And due to many vulnerabilities and a short key length, WEP was replaced by WPA, so this is false. Diffraction has what effect on a wireless signal? The signal is split into secondary waves. They continue in the direction in which they split. That's diffraction. RFID, when using RFID, what is a active reader passive tag? And it's a tag that is activated by the active reader and uses the power from the reader's radio to power its transmission. And all wireless signals are carried through the air by electromagnetic waves. That is true. And then our evil twin attack is a malicious access point. It's configured with the same SSID of a non-malicious access point, public access point. And then our 802.11 data frame contains 4 address fields in contrast to 2 address fields of the 802.3, and that is true. Okay. Chapter 9. If someone is offered a free gift or service in exchange for private information or access to a computer system, what type of social engineering is taking place? C, right? Quid pro quo, right? They give you something for something, right? The concept of giving employees and contractors only enough access and privileges to do their job is known by what term? D, minimal access exposure. A, least risk privilege profile. They're close, right? These are all kind of very close to the meaning too, but it's the principle of least privilege. Principle of least privilege. Yeah, I mean, it's pretty close to saying all the same thing with there. So that was kind of hard, but it's the principle of least privilege. How often should you require a user to change their passwords? According to the book, it is C, right? Every 30 days, according to the book. Right, yeah. I think by default, most software and stuff is set at 90 days. Yeah, right. I know 30 days. I would hate to change my password every 30 days. But that's what apparently is recommended by the book. Sudden unexplained increases in file sizes and unusual error messages with no apparent cause are both potential symptoms of a viral infection. True, right? Yeah, it's very likely you've got something, right? Uh, the term malware is derived from the combination of the words malicious and software. True, yes. Yeah. A variant of BYOD, or bring your own device. What does CYOD allow employees or students to do? B, supply a choice of cloud application or storage. I'm gonna. I have no idea, but so I'm gonna go with A, as choose your own device from a limited number of options. But I've never heard of this term. That's a good one. We'll find out. Yeah. But it sounds like this would be it, that you'd have limited options and they could choose, at least giving them some options. Um, a, a drop ceiling could be used by an intruder to gain access to a secured room. True, yeah. Utilized by China's so-called Great Firewall, what type of attack can prevent user access to web pages or even redirect them to illegitimate web pages? Hey, right, denial of service. Yeah. Current research indicates that a long random string of words such as correct, horse, battery, staple is more secure than random series of letters, numbers, and symbols that is short enough to remember. It is true. It is true, because you're going to have, that's a very long password, right? You got 4 words, and so it's very easy for you to remember, but it's going to take forever for somebody to crack something with that many letters. So yeah, it is actually easier and more secure. What type of door access control? It's less susceptible to dictionary text since it's longer. Yeah, yeah. I mean, it being so long, it's good. The problem is it won't fit with a lot of the applications and things. They have requirements because there's no special characters or anything, but you can add punctuation at the end of it, I guess. But then it could also be too long. Some applications don't allow you to go too long, which I find insane. Yeah, yeah. I used to add what I need, but character length is a major problem. Yeah, exactly. What type of door access control is a physical or electronic lock that requires a code in order to open the door? B, yeah, cipher lock, right. Which of the following statements correctly describes the malware characteristics of polymorphism? B, polymorphic malware can change its characteristics every time it is transferred to a new system. That is correct. Yes, good job. What penetration testing tool combines known scanning and exploit techniques to explore potentially new attack routes. D, it's a scan tool, right? But it's actually it should be Metasploit. Metasploit should be to create and do new attacks. Yeah, because it's using known exploits, right? Uh, a virus team that remains dormant until a specific condition is met, such as change of a file or a match of the current date, is known as what type of malware? D. No, it's not a boot sector virus. It's a logic bomb. Yeah, B, right. Yeah, logic bomb, because it's waiting for some action or date. You know, it's got some logic. It checks and says, do I go now? Okay. Yeah. Yep. Which of the following utilities perform sophisticated vulnerability scans and can identify unencrypted data such as credit card numbers? See, yeah, this is the NESA. Yeah, it is. Yeah, NESA is the vulnerability scan, whereas the Metasploit, it has the exploits in it and used for attacking, whereas Nessus is a good vulnerability scanner. VMware's AirWatch and Cisco's Meraki system managers are both examples of what type of software? So glad I've used it before, so I vaguely remember. Oh, you've used NESA. Okay, yeah. But I can see why you would get confused, as a scanner or attacker. Hey, you don't know about this one. Okay. Um, yeah, it's a they're mobile device management softwares. Yeah. So on Linux-based systems, what command can you use to create a hash of a file using SHA-256? You're not sure on this one. Well, that's good because I'm not really sure on this one either. I've never dealt with that on the Linux system, but I'm gonna go with this. But yeah, something I've had this on other exams somewhere, right? I don't want to say, but I unfortunately have never used the SHA-256 on a Linux system to actually know it. Um, it is ideal to use the same password for multiple different applications, provided the password is complex enough. False, right? Absolutely not, right? At least, definitely not recommended. Which command can be used on a Windows system to create a hash of a file? C, compute file. Okay, I could. SHA-SUM. No, I believe it's this get file hash. Yeah, yeah. It because this follows the PowerShell format is why I'm going with this one. Because some PowerShell commands have a lot of gets dash in them. Where would restrictions? I thought chapter 9 was pretty reliable till the last few questions. Yeah, yeah. I don't know where these are coming from really. From a networking standpoint, I don't know where some of these are coming from or why they're more. I mean, it's security related, but hashing and all that, it just yeah. not sure. Yeah, exactly. Yeah. Where would restrictions regarding what users can and cannot do while accessing a network's resource can be found? D, yeah, acceptable use policy. That's good. Yep. And which statement regarding denial of service attacks is accurate? B, yes, right. A denial of service attack prevents legitimate users from accessing normal network resources. All right, let's see what some of these are that we got. Got a couple of them, but now, so we missed one. All right. So quid pro quo is someone's offering a free gift or service in exchange for private information. Principle of least privilege is concept of giving employees and contractors only enough access and privilege to do their job. Oh, it's every 60 days. Ah, every 60 days. I thought it was every 30 by the book. All right. Still, default's usually 90. I knew it wasn't 90. uh, but yeah, because a lot of places it's 90. Most companies I've ever worked in, it's been 90. I knew that wasn't it. So by the book, it's every 60 days. All right. Sudden unexplained increases in file sizes and unusual error messages with no apparent cause is a symptom of viral infection, which is true. The term malware is derived from a combination of words malicious and software. CYOD is they can choose a device from a limited number of options. So, okay, that's what I figured. Like I said, I had never heard that term, but that seemed logical for me. A drop ceiling can be used by an intruder to gain access to a secured room. And then, right, a denial of service attack utilized by the Chinese so-called Great Firewall is an attack that can prevent users access to web pages or even redirect them to illegitimate web pages. Current research indicates that a long random string of words, such as correct horse battery staple, is more secure than the random series of letters, numbers, and symbols. And what type of door access control is physical or electronic lock that requires a code in order to open the door? That is a cipher lock. And which of the following statements correctly describes malware characteristics of polymorphism? And its polymorphic malware can change its characteristics every time it's transferred to a new system. Makes it hard to get with virus scanners and that. And then Metasploit is the penetration testing tool that combines known scanning and exploit techniques to explore potentially new attack routes. And a logic bomb is a virus that remains dormant until a specific condition is met, such as changing a file or a match of a current is known as a logic bomb. And then Nessus is the utility that performs sophisticated vulnerability scans and can identify unencrypted data such as credit card numbers. And VMware's AirWatch and Cisco's Meraki are examples of device management software. And yeah, that's what I thought this was. The SHA-256 SOM is used on Linux systems when you need to create a hash using the SHA-256. Like I said, I've seen this on my security exams and security classes and all that. But yeah, why that's here on a networking, I'm not sure. But hey, at least now we know it's SHA-256 SOM. It is ideal to use the same password for multiple device applications, provided the password is complex enough, and that is false. Get file hash is a command we could use on Windows systems to create a hash of a file. And where would restrictions regarding what users can and cannot do while accessing a network's resources be found? And that's in the acceptable use policy. And then which statement regarding denial of service attack is accurate, and it's a denial of service attack prevents legitimate users from accessing normal network resources. So those are chapter 6 and chapter 9. So make sure you go over them, because we only saw part of the questions. There's, you probably need to go through it 4 times, maybe even 5 to see all the questions. So, make sure you do that to study for the exam, because there's definitely some questions out there that are very unique. We'll say that. But so that is, do you have any idea if fall classes are online or in campus? Yeah, no, that's fine. As far as I know, all classes that can be online will be online. There will be some classes that will meet, but that's because, kind of like the airplane mechanics, things like that, something where you actually have to be there in the class, but as far as I know, everything to be online in the fall that can be online. Yeah. Yeah, that was passed to me. So yeah, and I know all my classes in the fall, they've removed the day and time meetings and room numbers on all my classes. So it'll just be there, and because they're online. A good question. Anything else? Nope, you're good. Okay. Well, that's all I have for this afternoon. But please, yeah, the switchport and ACL. Okay. Switchport and ACL. Um, is it difficult or straightforward? It's fairly straightforward. Is that in week 8? Yeah. Okay. Yeah, right. So. Right, project IP subnetting's due next week, right? Oh, so it's not due. Week 9. Okay. Uh, okay. So lab switchport security, right? So security doc. Yeah. Okay. Yeah. This one should be fairly easy, right? So you got 2 PCs, configure the switch. Yeah. This one's gonna. It's very, very simple, right? Um, why do I have all that? Because, yeah, I guess, yeah, I give you everything really to do it. So, yeah. So just a hint, right? So, I mean, you can copy and paste this into the command line and it'll set it up. Yeah. Yeah, you're going to want to use the command line interface, right? Yeah. I don't think you can do it from the config window. Yeah. Yeah. But yeah, so it's pretty straightforward, pretty simple. Yeah, and it follows the capstone project 10-1. Ignore the page number. I don't think that our online thing has page numbers, but it's the same. If you did have the actual book, it would be found on page 609. Oh, it does have page numbers? Oh, okay. Okay. Yeah. Yeah. Then that works. Yeah. Yeah. So then it should be page 609, hopefully. But yeah, so it's a fairly simple lab. Yeah. But good question. Good question. All right. I do appreciate your Ackles is the Ackles. Okay. I think it is, but add one of the following devices, routers, verify you can ping from all, right? Yeah, create access lists, right? Switch to configurations, add the IPs there. Yeah, right. You're just creating an access list, um, right? You know, you're creating an access list to deny, and then you're creating an access list to permit, and so you're running through that, um, right? So yeah, it's not too bad. Wanted to finish the lab. Studying from home is not conducive with family. Ah, okay. Yeah, I hear you. Right. Yeah. No. So yeah, the Ackles lab. It's fairly straightforward. I mean, really, it's these two lines of code really that are new. Yeah. Um, but yeah, it's rough being home. I know. Yeah. Yeah, online learning is rough, and with everybody at home and everything, it makes it challenging. Yeah, yeah. Uh, but yeah, with the Ackles list, once again, it'll be from the command line. But yeah, it's pretty straightforward and simple. But yeah, this one doesn't have a project though, um, or a book, so but it's not too bad if you know with the access list. Um, uh, it's if you look up and how to do an access list, it's yeah. I mean, it's pretty much this is almost the command really, but uh, but yeah, it's fairly simple. See, apples are pretty straightforward. We went over them in InfoSec. Oh, okay. Yeah, had a lab where we made one. Okay. Yeah, good. Yeah, you're very welcome. I appreciate all your questions and involvement. I really do. And just it does make things go uh, very well. So I do appreciate you both, coming on and doing this. So uh, it makes a difference. It helps out the class too. I'm going to stop the video, but